Okay, then we're on page 190, number 137. Plane is heading north for 45 kilometres, then it flies northeast, which of course will be out this way at 45 degrees if it's northeast. Just add some extra lines in here, might be helpful. And it heads that way for 61 kilometres. And the question says, how far north and east of the start is the plane now? So if we want to know how far north of its original starting point it is, here's the plane now, some wings on it, then it's going to be this distance here in total is how far north it's going to be. So we clearly need to find this length here and add it to the 45, and that will tell us how far north it is from where it started. So we've got a couple of things in there to help us. Here's an angle. This would be the hypotenuse of the smaller triangle, and this would be the adjacent side. An A and a H, we could use ka. Cos of 45, ka, equals adjacent over hypotenuse. So working out x, it's going to be 61 times cos of 45. And that's 43.133. So therefore the distance north is going to equal that plus 45 kilometres. This bit here we need to add on to x to get the total distance north, which will be 88.1 kilometres. That's to one decimal place. Right, now the total distance east from the start down here, this direction, we want to know how far in this direction has it gone, how far east of where it started is it now. So that would be that length there. We'll call that a y. So because that's 45, it's an isosceles triangle, isn't it? That must be 45. Makes it isosceles, so in fact this distance here is going to be the same as that one that we've already worked out. So the distance east we've already worked out is 43.1 kilometres to 1d the p, and that's because that's isosceles triangle. You could go through the motions using this and you'll discover that this is the adjacent, this is the hypotenuse, and you'll be writing the same calculation. Right, now it says how far is it from the start. So quite difficult to draw, but we need this distance all the way down here. So filling in more triangles, this distance here, which I'm going to call little z. We can use Pythagoras' theorem. We're going to need to know this height, which we've worked out as 88.1, and this one here, which is 43.1. So we've done all the work. We just need to write down that z will be the square root of this northern distance and this distance along here. Now these are, I'm using rounded numbers, so the answer will be quite rounded. That would be kilometres, and that's rounded to 2 sig fig.